Okay, greetings. Today we're going to have some fun with some neodymium magnets. Now these are 3/4 inch by 1/8 inch thick coin magnets, and I took all the spacers out. Those are some of them. I bought them for like $10, I think, off Amazon, and in a 10-pack. And of course I got them all stuck together, and these are 8 of the 10 right now. I wanted to show you, if you want to buy some of these yourself, what a good way, if I can mess with this stupid ass camera, I can't find a more better tripod than this yet. The best way to do it is take it up next to a table, and this is a huge stack, and I don't know if I can do it at this angle, but you got to just kind of slide them off with your fingernails, and it takes a lot of effort. I don't know if you can see this or not. Hell. Get away from me. These things are really funky. And another one. Damn it. Like a shooting gallery in here. These things are really fragile too. I haven't broken one yet until maybe now. But you got to be careful with them. It gets easier to break them apart. Like if there's in twos, it's not so bad. I mean, it takes some force, but they come apart pretty easily in twos. But you get a big stack like that, of course, the combined magnetic force is unbelievable. Anyway, I'm gonna go ahead and damn it. Stick to everything. Worse than silicon caulk. Some of which I got on my fingers. This is a pretty thick table here. It's over an inch thick. And, of course this works quite nicely through that. So, and even if you take an aluminum block, let me try to set this down without the magnet stuck to it. But this is, it's a magnet on a solid block of aluminum. This is, I don't know, good, roughly 3/4 inch thick, by a couple inches wide, by a few inches long. And of course, there's quite a resistance when you scrape the magnet across it. And of course, a bigger stack, offers quite a bit more resistance, which is nice and dandy. But even through aluminum, you got a good attraction between these sets of magnets, 2 on the bottom and 1 on the top. It's very strong. In fact, even through plywood, now I've got one underneath here under the table. This is the other 2 out of the set of 10. On this rough surface of plywood, works pretty nicely. But yeah, on the block of aluminum, there's a reluctance, for the magnets to slide off. When, if you take something like this thing, it just slides right off. Whereas this, it's quite a bit reluctant to slide. You know what I mean? And there's, that's why I use these in various stacks, because some of these experiments, you're better off with fewer magnets than more. And you'll kind of see that some of the tests I'm going to run in this series of videos, that I don't often use the full set of magnets, you get actually better effects out of smaller magnets, or smaller numbers of magnets rather than a whole cluster. You know, there seems to be a certain sweet spot, you know, between the mass of the magnets and how much magnetic force you get. So, like I said, this produces far better results, for example, than the single magnet on this block of aluminum. Well, actually, it's about the same. Oh, damn it. Oh, damn it. And it's about the same here. Okay. So, I really need to find a better tripod than this. This sucks. I have to do this one-handed. Like I said, it kind of oozes off. Let me set these out of the way a little bit. And then, like I said, with a bigger magnet, it'll tumble. See, so, you know, in this case, but you're going to see some other experiments where you really are better off with fewer magnets rather than more. But, you know, I just wanted to give you this video as a little bit of an introduction. I got some other experiments in my other videos that I'm going to do, and you can check those suckers out, and they'll be, promise you, very entertaining. This is just, you know, the basics of a neodymium magnet. But again, these things are fragile. Most of my experiments are going to be on cushions and carpets and stuff. Although they've been tougher than you'd expect, especially for how much they've been slamming together. But these can break, and they're very brittle inside. Because these magnets, you know, the actual neodymium, you know, is on the inside, and this is actually encapsulated in a nickel coating. I think it's a tin nickel coating, which gives them some toughness, but the inside of it is actually very brittle, very powdery. Therefore, these are very hard magnets too. Anything that is extremely brittle also tends to be extremely hard in nature. You know, that's just kind of a rule of thumb in metals and metallurgy. So, you know, like drilling a hole through magnets like this, for example, would be an exercise in futility. I saw somebody on the internet asking that question. Rather, you can drill a hole in these things, and it's better just if you need a hole in a magnet, buy one with a hole already in it. But yeah, these magnets are cool, and they come with all kinds of different sizes. And in fact, you know, I originally bought these because I was thinking about making some gizmos that stuck to refrigerators. I was like, well, I've never messed with these magnets before, so I don't know, you know, how strong they need to be. So, you know, I was thinking I didn't want too small of one. It may not work, but the fact of the matter is, yeah, if I was going to stick something to a refrigerator, even something that weighed a bit, a much smaller neodymium magnet would do this. You know, probably just a half to a third of this diameter would be fine. I mean, these things are so freaking powerful, it's unbelievable. And in fact, that's what's funny about these things. I never thought really much about it, because I was like, oh, well, electromagnets are a lot stronger, but, you know, but in fact, it's actually pretty difficult to get an electromagnet, because some of these magnets, you know, these magnets generally are between 1 and 1.4 Tesla. So they're extremely strong. And even though, yeah, you can do, you know, super magnets, which are, you know, up to upwards of 20 Tesla or more, you know, without going to superconductors, I believe. The fact of the matter is that, you know, holy geez, you know, these things are really hard to match, you know, with just typical solenoids. It's apparently fairly tricky to even make a 2 Tesla electromagnet. So these things actually, I've got a lot of respect for them, you know, a lot more than I have, because I mean, I really hadn't done much engineering around magnets in my time. So I just, you know, I'm kind of, you know, just learning some particulars about these things through this. But at any rate, catch some of my other videos, and you'll see some of the other little tricks we're going to perform.